Hi everyone, I'd like to present my paper which is submitted to the first conference on Internet of Things and Embedded Intelligence held in Yogyakarta in July 29, 2020. My paper is entitled Design and Characteristic Assessment of Wireless Vibration Sensor for Buildings and Houses. Vibration sensor is aimed to detect, measure, or minor vibration. Minor vibration can be mechanical or industrial vibrations, while major vibration may include tunnel movements or even earthquake vibration. Some vibration issues covers sensor, its network, and its applications. Vibration sensor issues include optical sensor, piezoceramic, electrochemical sensor, nano generator, thin film, and magnetic sensor. And sensor research issues uh, may consist of animal population monitoring, agriculture application, environmental monitoring, security surveillance, smart buildings, and healthcare applications. While sensor application for building monitoring mainly to determine building performance, building security, and also object localization. And this research focus on the sensor application for building mainly in installations characteristic. Sensor design in our research made of uh, sensor chips of MPU 6050 controlled by an Atmega 328 microcontroller, and the data is sent through the free license radio in 433 MHz frequency by using an amplitude shifting modulations. And then in the receiving point, data is received by the ISCA receiver controlled by Atmega 8 microcontroller and passed through the PC for monitoring purpose. The sensor node can be powered either by using power line or batteries. As sensor is implemented for building monitoring, power line is always available. So in our assessment, the sensor node is powered by using 220-volt power line. And then we evaluate the sensor assessment by using free fall vibration source by using 3, 6, and 9 kilograms vibration source, and we put the sensor on the base material made of either aluminum sheet or ceramic. We implement the sensor node by using either sleep mode or normal mode. And also we apply data validation technique by using peak detection, as it is a simple validation technique in sensor node. As a result, we can see that the vibration sensor MPU 6050 has three components of vibration: x-axis, y-axis, and z-axis. The assessment show that the z-axis has the highest vibration acceleration, and then the characteristic of vibration sensor so that the detected vibration occurs only once during the monitoring. So the source of vibration characteristic is uh, sporadic. Next, the impact of the source and distance can be seen from these pictures. The first one we see that the acceleration, the vibration increases for the vibration source increment. So the higher the more mass on the vibration source, the higher the vibration detected. And then we see in the second picture that the uh, distance of sensor and the vibration source point, the closer the distance, the higher the detected amplitude. And the impact of the base material, we can see here that the aluminum sheet exert higher detected vibration than the ceramic material. So the more vibrate material produce higher vibration amplitude. And now the detection period. As we can see here, the more frequent detection occur, the higher the average amplitude of detected vibrations. We see here 150 millisecond gives 0.1564 G, while 250 millisecond only gives 0.1049 G. But in contrast, the more frequent detection, the higher the power consumption. As we can see here, for detection period of 150 milliseconds, it consumed about 3.10 milliwatt, while 250 millisecond detection period consume only 2.39 milliwatt. And when we apply sleep mode in sensor node, here we can see from the first figure power consumption. The sleeping mode in the sensor node is able to decrease power consumption. However, the average acceleration the average amplitude of detected vibration decrease significantly. So while the processor microcontroller sleeps, and we can see it from the third feature, initial state microcontroller is sleeping. When the vibration occur at once, it detect and wake up. However, awake, when it is awake, the vibration has been gone, so it missed the detection. So we don't recommend sleep mode in sensor node for vibration detection. Next, data validation impact. Data validation is to detect invalid or valid data to send to the receiving end. However, the impact to the detection is minor because even though number of transmission is reduced and the power consumption also reduced, the average amplitude for the detected vibration also decreased. So it's it doesn't give significant results. So we don't recommend data validation for the vibration sensor. So to conclude, the device we use in this experiment, MPU 6050, produce three components of vibrations, and then the detected vibration is highest at Z axis, and detection efficiency is about 13% of the total vibration source, and then detected amplitude increase when the vibration source is added from 3 kilograms to 9 kilograms. Detected vibration also increases when the distance between the vibration source and the sensor closer. The material where sensor is attached influence the detected amplitude. The flexible material produce better detections than the solid material like ceramic. Smaller detection fluid result better vibration even though it consume more power. And then sleep mode and sensor node data validations are not suggested, are not recommended for vibration detections. Thank you.